No, there he is. All right. Well, here we go. We are talking today. This is the last of our workshops, I believe, on all the work that's been going on the last several months. And by the way, I thought I just saw a notice in my email box about Mayor Durkin doing something about banning fossil fuels. So we might want to take a look at that. But looks like we're going the way of San Francisco here in just about every way possible. So something new again, but we're trying our best to get ready to it. So welcome everybody. I think it's best, Lauren, given who we all are, if folks would be willing to put their name and affiliation in the chat box rather than going around the horn. We've got a pretty good group of folks here, and thank you all for participating. This is your time. We will do our best to provide some content and learning to you and get you acclimated as quickly as we can to the topics of balanced ventilation and the specifications that we're working on developing, what we're learning about the best way to go about it, and then maybe talk a little bit about how the balanced ventilation work is connecting to phase 1 projects, if at all available, at least some things that we've noticed in the work that David and Joe and others have been doing. So let's talk a little bit about where we're at, and I think all of you know this. We are dealing with both a climate crisis and an affordable housing crisis, and if you will, also an equity crisis that all intersect. And just a quick reminder that we are dealing with something that is so blatantly obvious as it comes to the reality of how people of color struggle with housing access and housing affordability. And so all three of these things intersect into this ecosystem that we're struggling with. And there are so many pressures on the housing development community, and not the least of which is what it costs. We also know, though, that maintaining and operating costs are increasing. And we know that we have evolving codes and regulations. Yesterday's workshop on codes, some of you participated in, continue to remind us that we're on that journey. And then talking about that journey, you know, when we get to 2030 or 2031, technically, we need to be using 70% less energy in our new buildings. And Seattle is intending to be carbon neutral by 2050, maybe moving that also to 2030. Obviously, today's announcement might get us there. So there are some challenges that we have to do, make changes to get there. If you look at 2018's performance, we're bumping up and really struggling with actually hitting those targets. And so we've got some ground to make up. And we think that, you know, some of the bigger areas here that we can take a look at are in the realm of domestic hot water, and some of the other areas that are going on. Plug loads is something else that we're taking a look at in terms of how we continue to improve our building performance. So, David, I think that's about as much of an overview as I need to give. I want to just remind everyone that the team of volunteers primarily working on this effort continue to work on guidelines documents that we will publish to the Exemplary Buildings website. Lauren will probably pop that address into the chat if you're not familiar with where that website is. And we're starting to accumulate some early learnings from the 4 and now 5 demonstration projects. So this is an ongoing effort, and it's a journey that we're all on, and we're glad that you're all on it with us. And David, I'm going to hand it off to you.
Great. Yeah, thank you, Marty. Yeah, you know, out of the intersection of these different challenges that we're struggling with is it kind of spawned the idea of the Exemplary Buildings program. As we're all here to talk about some of the efforts that are coming out of this. You know, I think at this point, most people are familiar with what is the Exemplary Buildings, or what is an exemplary building, and what is the program. And we emphasizing that we don't want to undermine the number of housing units produced, but we also want to build higher quality, more efficient housing that has provide the better quality of life for residents. And balanced ventilation is one of those things that's that really dovetails with that last point quite readily and apparently. Unlike some of the other things that we talk about in the Exemplary Buildings program, like hot water systems, you know, you still get hot water whether you use a heat pump or gas, but indoor air quality is directly coupled to the ventilation systems. Just a reminder that, you know, we do focus on affordable multi-family housing in our program, and that a lot of the conclusions and recommendations that we make are kind of grounded in these primary assumptions of using central water heating systems, primarily electric resistance for heat. So the general conclusions, although and lessons learned, though, can apply to other building multifamily projects. You know, recommendations do vary, you know, say when you go to using heat pumps in dwelling units. So just something to keep in mind as we talk about these lessons and guidelines that we develop. Just a real quick overview of the goals, both laid out, primarily laid out in a timeline here as we've established it, is to, we're still in our initial demonstration phase, developing these materials that we're presenting today, and others working to support the demonstration projects, with many of which are starting, some of which are starting to construction or in advanced stages of design, and sharing that information, and then with the goal of, in the next couple of years, scaling up those and disseminating those learnings, and in the future, more or less this becoming standard practice, especially as we see the codes evolve. It's coming, and that this vision idea of the Exemplary Buildings program isn't new or novel to, it is to this region maybe, but not throughout the country or the world. There's this model has been used in places like Pennsylvania, Massachusetts, and Brussels, where the idea is you roll out the goals, you provide incentives and training on how to do it, and over time pull back that extra investment, at least on the incentives, the monetary incentives to do it, and the result is it becomes standard practice, and energy efficiency overall improves just through the natural market forces. So this is intended to kind of illustrate how this workshop fits in, and other activities that we've done fits into the overall program approach. Primarily that, you know, we started over a year ago developing targets. What is an exemplary building? What are those specifications? And that led into a number of charrettes in each of the topic areas to suss out a set of guidelines and more refine those specifications further, and disseminate that, implement it in the demonstration projects as much as we can, and then bring those learnings back to what we define as an exemplary building. You know, do we want to revise our goals for wall performance or window performance based on modeling and costing and building that we do in the demonstration phase? So it's intended to be a feedback loop at multiple stages, all refining the guidelines and specifications that we work on. The focus topics, as many of you probably know, because we've had these workshops, are listed here. we're today going to be talking about the balanced ventilation with heat recovery focus topic. But on the Exemplary Buildings website are the videos and other presentations and guidelines and other documents we've generated in each of these focus topic areas. And just a real quick overview of where we're at, what we've completed. This Promising Practices workshop series will be completed after today. And it was, even though we're not done with the design guidelines in some of these areas, right at this point, we posted the wall assembly guidelines that you may be familiar with. We wanted to fast track these workshops to get this information out there to all the teams that may be pushing forward on design for the next, after the next awards are made for affordable housing this month and in the coming months. So wanted to get this out there. Who is the task force? At this point, there's a lot of people who know all of us, and just it's a team of professionals and primarily volunteers coordinated by HDC. And I think we're all, it's been, in my mind, a very impressive effort, a sustained effort even over years here now of a lot of really dedicated people. So this is just a short list of, this doesn't have all the participants that we've had over the years, but just people to recognize. And again, emphasizing that, you know, these practices are relevant to all housing, not just exemplary buildings. So we really hope that people draw what they can from this work, even if they aren't able to commit to all of the exemplary targets. And so what are those targets? I'm gonna pull back from going through this in too much detail, other than we're focusing on today that this addresses one of the high-level targets that we've established in the exemplary building program, which is to utilize balanced ventilation with heat recovery, which when we started developing these was not required by code, but will now be required as of the 2018 Energy Code for multifamily. So the code is caught up with the exemplary buildings program. So we're focused today on moving forward our recommendations for how to accomplish that and to go beyond code as we do recommend in some areas. So with that, we're going to jump into the meat of today's workshop. First kind of establishing, why are we doing this? Why are we changing how we ventilate buildings? Code is the principal reason, but what led to that is really considering where, fundamental questions like, where is our ventilation air been coming from? Is it actually coming from the outside as we intend it to be through these openings that we put in our tighter and tighter building envelopes? And as we do build tighter envelopes for other reasons, energy and building durability reasons, how does the ventilation strategy need to change in order to take advantage of those improvements in the envelope? Most people agree that there's a limit to how efficient you can make a building by using exhaust-based ventilation, because fundamentally you need to draw that air from somewhere, and it typically has to come through the envelope, or the wind, or some other opening. And if you tighten everything up, you're not going to be able to pull that air into the dwelling unit. So, what is the best way to provide that fresh air? And the consensus is migrating towards using balanced ventilation with heat recovery. Just a quick note unlike some of the other guidelines that have been developed, like the wall assembly, the balanced ventilation with heat recovery guidelines will focus more on educating teams on the different factors, the pros and cons of system configurations, and other metrics that people should be aware of when they consider different system types, to educate and inform, and not necessarily dictate that what is the only solution that people should be using for achieving this goal. So it's not as prescriptive as say the solar or wall assembly guidelines might be. It's more, they'll focus more on education and filling in gaps where code doesn't, and best practices aren't yet established yet. Try to fill in those gaps. The rationale, the pluses and minuses of this technology are primarily that you get better indoor air quality, you get better delivery of ventilation air to the dwelling units, which has a number of benefits. You're not pulling air from your neighbors. You can make the building tighter because you're focusing your where you pull the ventilation air into the building to specific openings, and for that reason, I think people agree that that reduces the strain you put on the building envelope by trying to pull air through it. So the minuses are that comes with additional cost, both upfront and maintenance, and it takes more effort to design these systems into our buildings, and it can take up space, and they actually can use more energy than that baseline of a whole house exhaust ventilation fans if you don't properly optimize the design. So there's a delicate balance here, but I think primarily the better ventilation quality and ability to extend the life of the building envelope it outweighs the minuses. We are all now staring down the barrel of the 2018 codes. The state code will come in effect on February 1st of next year. And my understanding, the Seattle code, the latest I heard was mid-March of the Seattle codes become effective. So with that change, we will be required to do balanced ventilation with heat recovery for Group R dwelling units. So we're gonna be doing this. Projects you probably all are involved in are already looking at how to do this. If you're not part of the demonstration, exemplary building demonstration program, I imagine most of you are looking at projects that will fall under the new code. So let's figure out how to do this. What is a balanced ventilation? There is a code definition of what is balanced. It just means that your air that you mechanically supply to the apartment home is within 10% of what you exhaust. You don't have to account for intermittent exhaust sources like the range hood or dryer, for example. So you don't have to supply more air just to account for these intermittent sources. We'll talk about a concept called distributed versus not distributed systems. That's an important distinction in the code, and that fundamentally this is similar to what is principally done now with whole house exhaust, is that the fans run continuously and they operate separate from any HVAC system. That's our recommendation. That's generally how this is going to be done, and is best practice. So when you look at the flow rates, one consideration is that with this move to balanced ventilation, the code actually recognizes that the balanced ventilation system, it provides a more reliable delivery of the ventilation air. And therefore, it actually reduces the code required volumes 25 to 30% lower than what was required in the 2015 codes. So that's one trade-off. Smaller fans potentially needed, smaller ductwork, and so that's one trade-off when going to balanced ventilation. But that does depend on your distribution design, and to capture that lower airflow requirement, that you need to accomplish a system that's designed to be distributed. And what that means is that you're supplying air to habitable spaces, the bedrooms, the living area, but you are also exhausting it from your bathrooms, which is quite typical, but you're as well as providing a local kitchen exhaust. And this attempts to kind of illustrate that idea, primarily that if you don't have an exhaust source pulling from your kitchen area, it's not connected to your kitchen hood. It's just and that's shown in this clouded region, where the one on the left is a distributed system, and one on the right is a non-distributed system. Just omitting that exhaust source connected to the ventilation system makes you a non-distributed system. So if you do that, then you need a non-distributed system requires 25% higher airflow. So you're kind of back to the airflows that would be required under the 2015 code. So just something to keep in mind when laying out your systems. Sometimes it makes sense to not do a distributed system, especially if you have the capacity in your ERV and just want to move more airflow. So this is something that teams will need to consider. When it comes to ventilation heat exchangers, so we have balanced ventilation on its own, just means you're using a fan to supply air to the space and you're using a fan to exhaust it. The heat recovery part is where you're actually exchanging, generally within a little box, the airflows don't directly come in contact with each other, but they transfer the air through a heat exchanger to effectively preheat or pre-cool the air that comes from the outside before it goes into the space. So it's a way to save energy by utilizing the room air to temper the air that comes from the outside. There's a couple different designs of those heat exchangers. A plate heat exchanger uses a series of plates that are stacked, and the airflow indirectly passes against with respect to each other. And then a wheel is a rotating disc that extracts air from one side, and as it rotates, rejects or transfers the air to the other side. And then what we call ductless heat exchangers, which we won't focus on too much, but it has its places, particularly in smaller dwelling units, where you might use a ductless heat exchanger designs. In the guidelines, we speak to the types, primarily an HRV versus an ERV. You maybe all have heard those terminologies. HRV is heat recovery ventilator, and ERV energy recovery ventilator. The principal difference is whether it recovers latent energy from your room air and transfers it to the outside air. The general, in our climate, in my opinion, it's not, when the type of technology used, HRV or ERV, is not particularly critical. Using either should be fine. Generally, you're trying to not maintain moisture in your dwelling units. We can have problems with high humidity, and that being an issue. But in the winter, we generally do have lower humidity, even though it's raining out. The relative humidity of that air when it comes inside is low. So I think this is something that can utilize more consideration, but sometimes you're limited by the type of equipment that you're going to be using, whether you can get an HRV or an ERV in the same package. So, and for this presentation, we're pretty much going to use the term ERV as a generalized term. And it could mean HRV as well. It's just what's in the box, but we're going to use ERV from here on out. I already talked a little bit about the difference between our plate and wheel, and there's kind of some information that we provide on the differences. Some of the high the high points that I think are important are plate heat exchangers generally have lower cross leakage. We'll talk about that in a second than wheels, but that doesn't have to be the case. Generally, you'll only find plate heat exchangers in the small unitized equipment that are used within dwelling unit, whereas in wheels would typically only be found in centralized equipment. And then there's other considerations on control of the air of the temperature of the air that goes to the space that are different between the two. Whether or not it has a bypass, for example. We can talk about that in an upcoming slide. One of the principal metrics that people should be aware of with these systems is what is the fan power? In my opinion, this as an efficiency measure, balanced ventilation with heat recovery as an energy efficiency measure really hinges on your fan power. Because we have a relatively mild climate, the potential for heat recovery it's helpful, especially if you're using electric resistance heat. But if you're using too much fan energy to move that air, you can easily kind of miss out on the possible higher efficiency for the recovery part. So, and unfortunately, all this ductwork and these heat exchangers that we're talking about, all those things have a general tendency to increase the amount of energy it takes to move the air. So this is an important metric to be aware of. And what you can think of it as is what is the total power needed by those two fans, the supply fan and the exhaust fan in terms of watts, divided by the outdoor air delivered, the CFM. It's a watts per CFM metric. So if you hear that coming from your engineer as this is the watts per CFM for this system, and this one, the lower the number, the better is what you're looking for. And the Exemplary Buildings program attempts to put a target on that. Another metric is heat recovery effectiveness. This is basically how good the heat exchanger is at transferring that air from the air that you exhaust from apartments to the outdoor air that you pull in. The higher the number, the better. But to get very high numbers, you either have to make your heat exchangers bigger or increase the design could increase the fan power needed to pull air through the heat exchanger. So it's a balance. So it's something that you should also be aware of, that when products are compared, this is an important metric to be aware of. And again, the higher the number, the better. Oops, sorry, going the wrong way here. Cross leakage. So I mentioned cross leakage as it relates to the type of heat exchanger. This is a certified value, or the test methods for these equipment do require that this be one of the things that's evaluated. It's effectively how much of the air that you exhaust can be transferred over to the air that you bring in. Ideally, it's zero, which plate heat exchangers generally accomplish that, are pretty close to that value, fundamental to their design. But the wheels will have generally a little bit higher cross leakage. Cross leakage is important for transferring, you don't always want especially in centralized systems, you don't want communication of air among units. You want to minimize that as much as possible. and for odors, for potentially viruses. Although at these amounts of airflow that we're talking about, the impact is small, but is something to be considered. Unitized systems, which is where you have one ERV for every dwelling unit, completely eliminate this, the repercussions of cross leakage, at least with respect to communication between different dwelling units. So that's one aspect of the unitized approach that people should be aware of. So that's one metric that we'll be we attempt to put a target on cross leakage. And filters is another thing to be aware of. The MERV 8. So I don't know if people are aware of the MERV rating system for filtration, but it's effectively a scale that the higher the number, the more pollutants, particulate matter primarily, that you're filtering out of the airflow. And MERV 8 is the code minimum for ventilation systems, mechanical code ventilation systems. But MERV 13 is becoming more and more common, especially in commercial systems, that it achieves a certain level of efficiency on particularly the particulate matter. It's less than 2.5 microns, which is PM 2.5. You may have heard as the bad stuff that can get down into your lungs and cause problems. So the other part of it is that there's filters on the exhaust side as well of systems, and that's not as important because you're not filtering air that people are ultimately that gets exhausted outside of the building. But there is at least you want to protect heat exchangers from any grease that might be in the exhaust air, grease or lint or other things. So you do filter the exhaust side of these ERVs as well, but generally the threshold's lower. And then when you have kitchen exhaust, you want to have a washable filter because the chance of grease is higher in that air. So yeah, and then replacement is another big consideration for all of these system selections. Where do you have to go to replace those filters? Because they do need to be replaced typically every 6 to 12 months. And it depends on the type of filter and what how big they are, how thick they are, all those things play into the cost of the filters and that ongoing cost. One thing to be aware of is that filters do add to the fan power. They increase the pressure drop of that air, and that this chart, it just tries to show you that the thinner the filter, you all may be familiar with the filters you put in a furnace or in other equipment, and it's basically a cardboard box with some filter paper in it, and most of those filters are 1 inch or 2 inches thick or deep, and this chart just shows that the deeper the filter, the lower the pressure drop it is through that filter. So even going to 4 inches, which is more the standard for commercial systems, really helps bring down that fan power impact for doing better filtration. So this is a chart that just shows that scale of how good, say, a MERV 8 compares to MERV 13 and higher. And it really gets down to how efficient it is at removing particulates from the air. And MERV 13 notably is rated to achieve 90% or better filtration of particles in the size range that become most important in the PM 2.5 range. So compared to a MERV 8, which is less than 20% efficient at removing those particles. So the guidelines are going to be developed to address some gaps in the commissioning both the testing process, but also in design review. And these relate to just general design review considerations. But a lot of what the commissioning agent might be looking at is, that the calculations of what the ventilation required are provided. The location of the unit considers how you're going to maintain those filters on a regular basis, and then even how do you replace this equipment if you have an ERV in every unit? How is that unit going to get replaced? Because they will only last 10 to 20 years, as most HVAC equipment does. So, and then balancing is another thing that I see not well addressed in these systems. Is how is the system going to be balanced, and that oftentimes doesn't come up until the end, which can be too late. And then the grease filter I mentioned for local kitchen exhaust, that's something to note that isn't accounted for. And all these things play into the cost exercise of making evaluation of the type of system that you're going to use. And then in the field, a number of items that we're going to recommend people be checking when they implement these systems. And we always want to make everybody familiar with what are some good O&M practices. We talked already about the filter changing. Larger systems, centralized systems, do offer the opportunity more readily to increase the filter level. We're all now familiar with the wildfire smoke events that we have becoming to be each summer. And so with centralized systems, it's pretty straightforward to go put in a higher level of MERV filter to improve that air quality during those times. And of course, the elephant in the room is the COVID and in general viruses and transmission among the possibility of transmission among units through HVAC equipment among dwelling units. And this is, as with everything, COVID is evolving with time. There's some pretty good recommendations that are coming to light, some good research. I can't honestly say I'm current on everything, but I do, it is something worth discussing with your teams because it does play into the type of ventilation system you might be comfortable with, and the ventilation rates and other aspects of the design. So we're going to do our best to address this in the guidelines, but it's still an evolving science. So with that, I'm going to pass this over to Joe Giampietro to talk about the system layout options. I apologize maybe not for previewing this idea. I talked a bit about centralized versus unitized in the previous slides without really describing what that meant, but Joe's going to show you a number of options of centralized system distribution versus unitized as well.
Great. Hey, thank you very much, David. Great beginning of all this background information necessary for teams to decide how to proceed and meet the new codes, and to really create great breathing environments for their residents. My interest as an architect is really to make sure that when we're designing buildings that we're really looking at the most optimized system for that particular design. And there are a number of different ways of doing it, and they really rely on the layout of the building, the way the building works, the type of equipment that you intend to use, or the type of resident you're servicing. So let's move on to option A, centralized for the entire building or building wing.
Here we go.
Deciding how you're going to lay out your ductwork and your equipment layouts in a building is obviously critical, that you take it and you do this very early on as part of our early integrative design approach. So you really look at this right up front because number one, you have floor area you might need to adjust, need to provide routes for ducts either in floor systems or vertically. You have to provide places for equipment for the units themselves, either on the roof in this case where you have one or two units that are servicing an entire building. In this case, a centralized layout might, for example, as we did at the Bill Hobson Place Phase 2 project, deliver horizontally just under the roof and then vertically down to units on every floor from there. We had multiple units. I think we have the next one, maybe an example showing how it got laid out. So you can see this wing of the building on the right has two ERVs that are serving multiple units on multiple floors. And one of the benefits to a system like this is you can have a simpler management over time with fewer units to manage, fewer filters to change, possibly easier in operations. It gives, obviously, residents a little less control over what happens. Let's look at the next layout scheme, which is a different form of centralized, which is that you have individual stacks of units, maybe pairs of units that are served each by their own equipment. And what happens here is you can get away with having less horizontal runs. Your duct lengths are smaller. You're only serving vertical. And I guess you could say there's a downside to having more rooftop area encumbered than you would with the more central. An example here is the Estelle building, which has been up and running for a number of years, that really has one ERV for every pair of units in a stack. And it's a pretty efficient system. It may not give you as much flexibility on the roof layout as you would want. Next slide shows one of the other ways of a centralized system is through floor by floor. And this was done, has been done in many different places where you have the equipment on every floor, either inside or in a room adjacent to the floor. If it's centrally located, like we're showing in this diagram, you have smaller horizontal ducts serving down the corridor and back than you would have in another layout. And a local passive house project, Solus by Solterra, is one that's used a horizontal system where they have one piece of equipment shown in the photograph on each floor and serving, I think it's about 8 or 9 units there. And it works well. Again, it doesn't give you the individualized control that you might have with a unitized system. So the last one we want to talk about.
Oops, sorry.
Okay, going back to the various types of horizontal distribution. One of the things that Walsh Construction pioneered is how you get duct space in the ceiling, either floor by floor or at the top floor. And that is to use a different type of a floor assembly in the corridor, which is car decking instead of joists, to give you that plenum space to run the ducts. And something that we think is a good option whenever you're running horizontal ductwork. Next slide. And then the last of the different types of systems that are good to consider is the unitized, and probably in higher end multifamily buildings, this is what would be selected because it gives the individual owner more control over boost function. If they have a party, they want a lot more air moving through it. Rather than opening windows, they can use the ventilation system. And the downside, I think, is really that you have a lot more management of individual units, filter replacement, and so on. But it does give you a higher level of control and a little less expensive probably on the installation because of less ductwork. So maybe that's as much as we need to cover on the different layout systems, but to keep in mind that it's critical that you really do a thorough job before you really get into the design to decide which approach works best for your building type and your customer type. So with that, I'll hand it back over to you, David.
Yeah, thanks, Joe. That's a great overview of a kind of the major categories that we identified in the guidelines. And this table just is a high level comparison of considerations we recommend thinking about when trying to make the decision, do you go centralized or unitized in unit? There are pluses and minuses to both. And we really hope to just try and educate you all as much as possible so you can make that decision. And, you know, as Joe mentioned, just how critical it is to try and make that decision as early as possible, work through it, really even in schematic design of the approach, because there are building design, very, very significant building design implications with both. And in the guidelines, we have, again, trying to educate as much as possible the overall, some overall comparisons and impacts on cost, design, code considerations, and operations for the different decisions. So unfortunately, we don't have time to go in too much depth on any of this information, but it will be all available online for your deeper review. The effort that we've gone through ultimately is intended to lead to not only the education materials that we've shown, but also supplementing the existing set of targets or recommendations the Exemplary Buildings program has on ventilation. The ones in black here are the ones that were part of the original draft specifications. The ones in green are the proposed modifications that came out of the effort of working with, going through the charrette process with contractors, designers, architects to try and distill down what is an exemplary building in terms of ventilation. So we talked about effectiveness, that's the heat recovery effectiveness, fan power, but identifying MERV 13 filtration as the ideal. We talked about continuous operation as being important. Serving corridors and other common areas with these balanced ventilation systems is also something that we believe is part of an exemplary building. Instead of using rooftop units, we can't just only do it in the dwelling units, we should do it in other areas. Cross leakage, less than 3%. That is what the Passive House program has adopted. And this particularly for central systems reduces that opportunity for air to exchange between the exhaust and the supply. For local kitchen exhaust, that does play into the design of the overall system. Our initial recommendation is to duct that to the exterior, and that for very tight buildings, you need to ideally have a makeup air source for that. So cracking a window when you operate your exhaust hood. And then considering recirculation hoods for smaller units where less cooking is anticipated. But for all of these, whenever you have an exhaust source for the ERV system that pulls air from the kitchen, that there's a grease filter is installed in that exhaust grill. And then lastly, if you do have laundry in the apartment, that it is located within the bathroom or kitchen area, and using a heat pump dryer, that minimizes the impact on the makeup air, the outside air needed, because dryers, a standard dryer will pull air through the dryer, and that air has to come from somewhere. So if you're going to have a very tight building, that air needs to come from somewhere, and using a heat pump dryer eliminates that need for makeup air. And this is a table that just compares some of the exemplary building targets with respect to what is code currently. So we're recommending a higher level of heat recovery effectiveness, establishing a fan power threshold, whereas the code doesn't really address that fan power threshold very well right now for for residential applications. So I do anticipate in the next code cycle that there will be a fan power limit on all residential ventilation systems. We're just trying to get that out there now. And filtration, MERV 13 I mentioned, and cross leakage less than 3%. So just to wrap it up, this portion, you know, that we strongly believe that this ventilation strategy has some very strong indoor air quality and building durability benefits, in addition to saving energy. I mean, that does happen, but in my opinion, the other benefits trump the energy savings. And that we all need to work together to figure out how to do this effectively and reduce the cost as much as possible. Even though it's required by code, it's still going to be a challenge, and we can continue to learn and optimize. And as Joe mentioned and emphasized, an integrative design approach is really important to make sure that these systems are the efficiency that we all hope to achieve is sustained in the long-term operation. So I think this is Marty mentioned that we would try and give an overview of the demonstration projects. This is a table that I compiled for the 5 different demonstration projects that we have going right now. And just focusing on the ventilation strategy for now, what we have is a pretty good mix of centralized and unitized. We do have one that was before the earliest building brought into the program that wasn't using balanced ventilation, but was using accomplishing other targets in our guidelines. So it's a good mix that we hope to learn from all of these, because they do provide different insights and approaches. So with that, I'd like to open the questions.
Thank you, David. Questions that folks have about this particular content? You can either raise your hand or shout out or chat, whatever you would like to do, but we have a few minutes while you're getting yourself organized to ask your questions. I will just say, to the point of planning ahead and early integrative design, it's a decade ago, David and Joe, that I was actually working with my wife on weekends on habitat houses, townhomes actually, installing HRVs and trying to navigate getting the drain lines to work as an after effect. Was in and of itself a scientific experiment. So it's always important to think ahead, but we definitely know and have learned a lot in the last decade, and certainly can apply a lot of this to how we go forward. Thoughts, concerns, issues people have?
I'm interested to hear if anybody's working on a 2018 project that would be permitted on the 2018 code and has already made their decision on unitized versus centralized. Does anybody have projects to offer?
Hi, this is Bill Singer. We're doing one for 2018 that's small, very small, permanent supportive housing. That's probably going to be, well, we're looking at unitized just because it's the least expensive. I don't know for really small units. Well, they're probably similar maybe to what DSC is doing, and you're doing centralized systems there. Is that?
Yeah, that's right. Yeah, did you actually evaluate the costs of both centralized
We're
and?
just getting into that, but yeah, so that's going to be a next step once we get funded.
Right.
In 2 weeks, hopefully we'll know if the project's moving forward. Yeah.
Mhm.
Other thoughts, questions? Obviously, you guys did too thorough a job.
Hi guys, Elizabeth. Hey, thanks for the presentation. It's really helpful. I feel like I get overwhelmed every time I hear y'all about this stuff, but it's helpful. It's starting to sink in. That might be why there's not a lot of questions, but we are starting to see several projects that are going to be under the 2018. It seems like it's early. Most of them right now are still trying to get in before the date. It was interesting to hear you, David, say that you think it's going to be mid-March is the latest you've heard for Seattle.
Yeah, that was news to me just yesterday, actually. I wish Steve Gelb, I think Steve Gelb's been following it closer, but yeah, that's what he had indicated.
Yeah, so I've been trying to follow. What is the final? So I know there's been drafts out. There was a comment period. It's still in the not finalized state, right? For the Seattle, not Washington.
Yeah, Washington, yeah, it's definitely, I'm not aware of any possible changes there, but in Seattle, I think council will be considering it in January. I just saw today an email that came out on the SEPA review for it. So yeah. It's moving forward, but I'm not the best person to, unfortunately, give you the insight.
Yeah, no, that's interesting. I think everybody's been trying to get in by February. And now it's a little bit more time, so we might see some more slide in under the 2015. But I just imagine we're gonna be evaluating, you know, which way makes the most sense. I think it depends on number of units. It clearly depends on if the units are stacking, you know, or not. There's probably a few, but we've certainly done. I think we've done maybe all the kinds you listed. But it just really depends on what the building layout looks like. So I don't think we have a good sense of cost yet because there's some factors that it depends on.
Yeah, and NIA has actually expressed a lot of interest in centralized, trying to support and learn from more centralized systems. It's one of the things that I think is an important advantage is the ability to do some heating and cooling centrally. So that can kind of take the edge off of some of your peak conditions and overall make the building more efficient if you're using heat pumps centrally to heat and cool that air. So, you know, that might, if you incorporate other passive strategies, you could avoid doing cooling in units, which, you know, we all know that's another huge cost to start adding heat pumps in every apartment. So centralizing is maybe one in between step that could help.
So one of the things we're trying to focus on in this whole program is getting feedback. So we know what's happening in real time as much as possible with costs, with designs, with recommendations. And so anyone who is doing this kind of work, it would be great to have your feedback as you're going through it, something you learn, whether it's a cost factor or a design factor or a code factor. Those would be really great to be able to share with our whole HDC population.
Absolutely, Joe. We definitely need that. The more of that we can get, the easier it's going to be for us to all learn as quickly as possible about where the snares are and how we navigate this. So unless you feel like you have to keep your stuff, share liberally. We got to run people like David out of business, these consultants who own all this intellectual capital, you know.
And one way might be to get your clients' consent early on for sharing information that they, in some cases, might feel is proprietary.
Mm-hmm.
All right. Well, again, I think this is our last one for the year. We will be doing deep dive trainings in these areas next year. Focus especially on balanced ventilation and on domestic hot water systems. But the training will continue and be a little more detailed and in-depth, along with the guidelines, which we're hoping to put most of them out, we hope, by the end of the year. So good on all of you for participating. If we don't see you again this week, we'll see you next week at the HDC annual member meeting. And from there, let's try to get rid of 2020 together.
Agreed.
All right.
Yeah.
Thank you, Marty.
Thank you all. Take care. Wear your dumb mask.
See ya.
Hello.